Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental relationships. We are all about empowering teachers and students. We answer the question, if not algorithms, then what? All right, today's episode, we are going to spotlight a really cool addition strategy that some people may use naturally based on what they know and understand about place value. But for some of you, you may not even know it's a thing. Like I didn't. Like I had no idea that this was a thing to do, a thing to even think about for quite a while. I'm so excited that I do now because it's really empowering. All right, so Kim, we're going to highlight something that you did naturally growing up that I had never even thought about. To do that, will you tell us about the experience that you told me about with your son, Luke, the other day?
Yeah, sure. So I was talking with my son, Luke, and I asked him this problem, and it was 94 plus 39. And I said, hey, tell me what you're thinking. And he wrote down 93 plus 40. And I said, wait, tell me about that. And he said, well, the problem's 94 plus 39. So I'm just going to take one from the 94 and give it to the 39. And the problem that he wrote down was 93 plus 40. So he would just give and take a little bit.
So those are equivalent. And
right.
So he could use that to solve it. Cool.
Yep. And I said, cool. What else you got? And he said,
because that's what you do with your kids, right? What else you got?
You know what? I'm just realizing we didn't even ever solve the problem.
You just wanted to know what his plan of attack was.
Right.
Mathematicians talk about that. Yep. Okay.
I said, what else you got? And he said, oh, I could do this. And he wrote down 100 plus 33. And I said, how'd you get that? And he basically said that he did a little give and take the other way. He took 6 from the 39 and he gave it to the 94 to create 133.
Cool.
And I said, oh my gosh, that's so funny. I didn't do either of these ways. And he said, well, what did you do? And this is what I did. I wrote down 99 plus 34. And Luke asked why. And I said, well, aren't they equivalent problems?
Okay, so let me just hear that correctly. The original problem was 94 plus 39, but you wrote down 99 plus 34?
I did.
Wait, what? How?
So if the problem was 94 plus 39, right? It's kind of like having a 90 and a 4 and a 30 and a 9. And I just rearranged the ones that I wanted to put together, really.
Huh.
Can you picture that?
So it's almost like I picture a splitting model. 94 is made up of 90 and 4, 39 is made up of 30 and 9, and you brought the 90 and the 90 from the 94 and the 9 from the 39 together, and the 4 from the 94 and the 30 from the 39 together to make 99 and 34. Why would you do that? Why would you make 99 and 34?
So 99 and 34 is really nice because then I can just grab one from the 34 and give it to the 99.
99.
So you did a splitting model. Can you picture base 10 blocks? Like if you had base 10 blocks and you were building those numbers, it's kind of like just rearranging the ones from one number.
Sure enough. Yeah. So I can picture the base 10 blocks and you just literally would move the blocks around a little bit.
Sure.
And then since you didn't lose or add any blocks, you have the same numbers. Cool.
Yep.
Very cool. And then you have this brilliant problem, 99, 100 plus what's left over, and you can just solve it that way. That's really nice. All right, Kim. So you're sort of natural at this. Give us another problem that we can all work on that would work for this swapping strategy. What would be a really sweet problem that we would all want to swap a little bit?
Well, it's funny you asked because I actually gave Luke another one. Here's the problem I gave him.
Of course you did.
I said, well, what about 159 plus 92?
Okay, let me think. 159 plus 92. What blocks would I want to rearrange? I think I might want to take the 90 from the 92 and swap it out with the 50 from the 159. So the 159 becomes 199. And then I'm left over with the 50 and the 2. So 199 plus 52. 199 plus 52 is 199. 200 plus the leftover 51. 251. Nice. Bam! That is really cool.
Nice, right?
Really cool.
Okay, let me give you another one.
Okay.
The next one I asked him was 929 and 191. 929,
929. What was the second number?
191.
929, 191. I'm noticing lots of nines in here. Okay,
Mm-hmm.
so if I have that 929, I'm going to swap out the 20 in 929 with the 90 in the 191. So that now I have 999, and then what would be left over would be 121, right?
Mm-hmm.
121.
Mm-hmm.
So now I have 999 plus 121. So that's 999. 1,000 plus 121 is wait. No, I already gave the one. Hang on. 99, 1,000 plus the leftover 120.
Yep.
And bam, that's just 1,120. Woo!
Yeah, nice, right?
That is
So
really interesting.
yeah, so after I did those problems with Luke, I wanted to see if he had kind of a like handle on what I was doing. And I
Mhm.
asked him to come up with some problems where I kind of think about that like as swapping. So I wanted him to give me some problems where that would be a nice kind of slick idea. And you know what he
Okay.
did? I said, "Hey, give me a problem, maybe like a bigger problem where that might be a strategy that would be useful." You know what he did? All he did was add a 9 in the thousands place and increase the other number by 10. So he just created 9,939 and 191. Such a
Wah,
stinker.
wah, wah, wah. That's awesome. So then you could just make 9,939 into 9,999
Mm-hmm.
plus 131.
Right.
That's really nice because 9,999 is so close to 10,000.
Right.
Yeah, that's so his way of making a whole new problem was to just tack on a couple numbers and
Yes.
not really. Okay, cool. That actually shows really good place value, right? Like
Sure.
he often the laziest thing that somebody can do is kind of cool because you're showing that you really understand what's happening. So then when he did that, what did you do to push him a little bit?
Well, I
Because
kind
knowing
of,
you did, right?
yeah, I kind of eye rolled a little bit and I said, no, for real, give me something that's a little bit like more fifth, sixth grade. And so he randomly stuck a decimal point in the middle of those big numbers. And he just made 993.9 plus 19.1.
That's
Such a
awesome.
stinker.
Okay, so I actually want to think about that one. So
Okay.
993.9 plus 19.1. I'm
Mm-hmm.
going to swap out the 3 from the 993.9 and the 9 from the 19.1 to get 999.9 plus the leftover 13.1.
Mm-hmm.
Okay, so if I just give that 0.1 to the 999.9, now I have 1,000.
Yep.
Is that right?
Yeah.
Yes. So then I have
Ooh.
1,000 plus the leftover 13.
Yep.
And what is 1,013? It's 1,013. Okay, cool. Wow, seems really interesting and a great understanding of place value
Sure.
because Kim, you and I've talked about before that place value understanding is different than a lot of what units out there are called place value. Like I see a lot of third grade, fourth grade, sixth grade teachers, fifth grade teachers now, because the standards are calling for it a little bit younger to do decimal understanding. A lot of place value units. There's these units out there that are called place value, but in reality, they're much more about place labeling.
Yes.
Right, y'all. If you can
Yes.
think about the units that you have in traditional textbooks or anything, and it says place value, really think about what kids are doing in those place value units. They're really labeling a lot of places. Now, that's necessary. It is necessary that kids know the names of the places in our place value system. That's necessary that they can label those places, but it's not enough. It's necessary, but it's not sufficient. There's a good math phrase for you: necessary, but not sufficient. We need a lot more place value work. And I'm going to suggest that the kind of stuff that Kim and I were just playing around with, where we're kind of thinking about these numbers and their place values, and so we could just swap out the place values in two numbers, that's place value. That's really understanding the value of the digit depends on the place that it's in. That's what place value means. And to understand place value, to be really like conversant with place value, really own the relationships, then we need students to have experience messing with place value, not just labeling the places. So I'm going to suggest that we work with students with the swapping strategy, that there are some problem strings we could do to help students with the swapping strategy to develop it, not because students need the swapping strategy,
Right.
but because we're trying to develop mathematicians, and mathematicians play with relationships like place value. And because they understand place value deeply, then exploring the swapping strategy is one way to get at that deep place value understanding. You might notice that while we're playing with place value, we're also having to name the places a lot,
Right.
right? Like, so as we're playing with place value, doing the work that we just did, we had to name the places. We had to sort of label them. So we get a lot of practice with the labeling in when we do real place value work, because it comes out naturally. Both things come out naturally when we play with place value. If we're only playing with place labeling, that's all that kind of happens. So instead, we're recommending do something like mess with this swapping strategy, and students will understand both better, both place value and place labeling.
You're so right. In today's episode, we played around with place value and the addition swapping strategy. So, listeners, we'd like to invite you to join in on the fun by creating and sharing with us a problem that the swapping strategy would be so cool for. You can ping us on Twitter at PW Harris and tell us about that really gnarly problem that was made so much more doable by just swapping a little bit. We'd love to hear what you come up with and maybe make it a little bit different than Luke, where he just added another 9 or put on a decimal point.
Like, maybe come up with your own like cool problems,
Yeah.
or you could be a little lazy, but you can't use any of the ones that we used on the show today, right? So at PW Harris is where to ping me on Twitter. Love to hear your suggestions about what you think would be a really cool, slick problem that if you just do a little swapping turns into a problem that's much easier to solve. All right, everybody, we really appreciate when you like the podcast and when you give it a review. That helps other people find it. You can check out more about Math is Figureoutable at our website, mathisfigureoutable.com. We'd love for you to join us at #MathStratChat on Wednesday eves on your favorite social media platform. So if you're interested to learn more math and you want to help students become mathematicians where they mathematize their world, then the Math is Figureoutable podcast is for you, because math is figureoutable.